This is part 2 of section 11.5 about where the law of cosines comes from. So to figure out where the law of cosines comes from, we're first going to be looking at this triangle on the right, and it's got angles A, B, and C across from sides A, B, and C. So across from angle B is side B. This whole length is side B, and it's represented in terms of x and b minus x. So it's broken up into these parts. We've got x and then b minus x. A little bit sloppy, sorry about that. And so to look at where this law of cosines is coming from, it's actually taking these two right triangles. So we've got a right triangle here and a right triangle on the left side. And we're just going to rewrite these right triangles with the Pythagorean theorem. So if we write the Pythagorean theorem out for the triangle on the left in orange, this is going to be x squared plus h squared is equal to c squared. And writing out the Pythagorean theorem for the right triangle on the right, we've got h squared plus the quantity b minus x squared is equal to a squared. And we're going to go ahead and expand this equation on the right. We've got h squared plus, if you FOIL b minus x squared, that comes out to b squared minus 2bx plus x squared, and all of this is equal to a squared. Now looking at these two equations, they both have x squared plus h squared. So here we've got x squared plus h squared plus x squared. I'm actually going to rewrite that. So now we can see this is x squared plus h squared, x squared plus h squared. Because this quantity x squared plus h squared is equal to c squared, we can go ahead and substitute that in. So that's c squared plus b squared minus 2bx is equal to a squared. So now we're going to look at the cosine ratio for angle A. So the cosine of angle A is equal to the adjacent, that's side x, over the hypotenuse, side C. So x is equal to, this is side C times cosine of angle A. And looking up at our equation from this first section, we've got an x in here, so we're left with a squared equals c squared plus b squared minus 2bx. And we've got x right here. So because we know what x is c times cosine of angle A, we can go ahead and substitute that in. And when we substitute that in for x, we've got a squared equals c squared plus b squared minus 2bc cosine of angle A. And this is the law of cosines. And the law of cosines can be rewritten so that you can solve for an angle rather than just a side. We solved for an angle in problem number 1 in part 1 of this lesson. And another way that you can rewrite this equation so that it's in terms of solving for an angle is like this. So I just added 2bc cosine of angle A to both sides and then subtracted a squared from both sides. And to get cosine of angle A by itself, we need to divide by 2bc from both sides. So that leaves us with cosine of angle A is equal to, we've got c squared plus b squared, or b squared plus c squared, minus a squared over 2bc. So again, if you're solving for an angle rather than a side, it might be helpful for you to use this equation in this form. Or again, you can plug the numbers in as you usually would and solve for an angle like that. So we've got the law of cosines. This can be written in 3 different ways in terms of A. So this has a squared, and if you notice, it's aligned with angle A. So if you're solving for angle A or if you're solving for side A, then it needs to be in this form. If you're solving for side B or angle B, then it's going to be written in the form of b squared equals a squared plus c squared minus 2ac cosine of angle B. And the third way that we can rewrite this is in terms of c. So that's c squared equals a squared plus b squared minus 2ab cosine of angle C. And again, this is where the law of sines, or I'm sorry, law of cosines comes from. Go ahead and do the assessment. It's got a few questions on the law of cosines and where it is coming from.